Hello, and welcome to More Intelligent Tomorrow, a wide-ranging exploration of the potential impact of AI on the world around us, as envisioned by the future heroes of the human and machine intelligence revolution. Can advanced AI systems ever learn like we do? We'll discuss this and more with Anima Anandkumar on today's episode. And now, your host, Ben Taylor.
Anima, I'm so excited to talk to you today.
Same here, Ben. Really great to be on this podcast. And yeah, we're all aiming for a more intelligent tomorrow.
Do you think that we will see AGI in our lifetime?
Again, I'll quibble on the definitions because, what would AGI mean is always one about that's open to debate. But in my view, I think we'll see very exciting manifestations of AI to AGI somewhere in that spectrum, right? So certainly some forms of autonomous systems, whether it's fully self-driving cars, right, or not. Again, like if it's all the entire streets are lined with self-driving cars, certainly that's something we'll see. All kinds of delivery bots, all kinds of search and rescue missions, the Mars rover and beyond to Saturn and other planets having much more autonomous abilities to explore and make amazing new discoveries. So I think we'll see all that, and it's already happening.
And we actually had Chris Mattman on from NASA JPL talking about that exact reason, where the bandwidth to send all that information back is not practical, and you want an autonomous system, like you said, to go and do all the research and then only send back kind of this spark notes or the summary on what it's finding. It doesn't have to have the humans controlling it.
And that's where I think, because a lot of AGI we think of as massive brains, massive compute, right? But I think the missing story here is also miniaturization of AI and progression to AGI. More and more of the computation will move to the edge. We'll have this revolution where a small edge devices, right, with limited battery capabilities, having highly intelligent processing units. We already have the NVIDIA EGX platform with these capabilities, and then 5G, 6G, and beyond connectivity for very high speed, reliable communication, high bandwidth, and the ability to have that social swarm-like ability, right? So on Earth, we'll see all these kinds of capabilities. And for space, this is really needed because, as you said, as we go to more distant planets, the ability to communicate and control those bots is nearly impossible. So we will see more of the also innovations moving to the edge, which requires more efficient algorithms, right? Less power hungry algorithms. Our brain uses much less power than what current GPUs do. So how can we create more effective hardware and better training and inference methods that you can use on the edge? How do you more effectively decide to communicate? Don't always be communicating, but be strategic in that. I think all these are algorithmic developments we'll see in this coming decade.
Yeah, definitely. I'm curious, how do you define intelligence, or what's your working definition of it?
Yeah, for me, it's really the ability to learn, right? So the learning is so critical. Learn and adapt, right, to different environments, to any changes. So I think that aspect is missing if you see in many of the current robots. For instance, the Boston Dynamics robot can do impressive, dancing, backflips, open the door, but it's pre-programmed to do precisely that, right? So it's not like kind of learning on its own by observing others, or I don't know if you have dogs, but I've had dogs since I was a kid, and so dogs are so intuitive in seeing our actions, our kind of mental and physical state, and they can learn new skills so beautifully. So that's something that's still missing in our current robots.
And to pull on that thread with the dogs, I think sometimes we hyper focus on IQ as being the perfect measure of intelligence, but there are other. It's hard to have a dog go through an IQ test, but you can see behaviors. So dogs, they show, um, they have empathy. They're tuned into us humans when it comes to our emotions, if we're angry or sad, and but they also show, if someone passes away or dies, they'll mourn. They'll have more complicated emotions, which I think is really interesting. Where maybe the dumbest emotion or behavior would be I'm hungry, and then I'm worried about a predator, and then you go all the way up to elephants where they're very complicated in their social behaviors.
Absolutely, that rich social connections that mammals have, right? And that dogs have figured out how to connect with us in such a deep and intimate way. I think that requires both I know a very sensitive understanding of our actions. A lot of studies on dogs have shown how even humans, like minutely moving, like the body language, the dogs are so sensitive to that. So if you're like thinking of like getting up before you even like you think you're making a movement, the dog is already out there jumping, right? So because it knows that you want to take him for a walk. So I think this kind of sensitivity is something that's so hard for us to still program in our robots. And also I would say a lot of notion, especially right in the general public, the perception of intelligence is somebody who's smart in math and can solve giant math problems. I think that's historic because before we had powerful computers with lots of memory, you could not program this. I mean, even going to the moon, if you saw the Hidden Figures, which is an amazing movie, was yeah, such an amazing one. And so even there you saw it was all like through human intelligence, right? So that kind of intelligence was mathematical intelligence. And so historically that's been valued a lot, but now with the advances in computing, that's no longer, I think, in future the most prized quality. This also talks about the future of jobs, right, which is an important aspect on how AI will change this. And I think one thing that will be changed is, yeah, certainly, we need humans with great math skills to advance in creating better abstractions, better, right, unified theories, and better programming languages, for instance. I think that's still hard for AI to catch up to immediately. But mundane calculations, just brute force calculations, right? We can do it at such an impressive scale now. So that notion of what is human intelligence that's very valuable to humanity will also change. And in terms of how we can build this into applications, AI for science is where putting a lot of my personal energy into. At Caltech, I co-founded AI for Science, a campus-wide initiative to really connect closely with all different areas. One project where we've seen a lot of promising results is using AI to solve partial differential equations, right? That drive almost every scientific simulation you can think of. Predicting climate change, discovering new materials, enabling nuclear fusion. Everything is driven by partial differential equations. And it's very, very expensive to do this traditionally because it's massive calculations done brute force on supercomputers. And so, can AI speed this up, and how well can AI make an impact? And what we've seen is, for the first time, we can solve Navier-Stokes, which is a model for turbulent fluid flows, extremely complex. And we can use AI and be much faster than traditional simulations. So I think this broad area of AI for science is where we'll see a lot of exciting, groundbreaking discoveries and challenges met.
Do you think when we get to that point that humans would be smart enough not to upload a single consciousness? Instead, we do like a mean merge of the best traits of society. Like, what would you do, or what would you recommend if we could upload a consciousness?
Well, if we can get to the place where we can upload a consciousness, I think we can upload millions of them, right? So because it cannot. Yeah, and that's what has created this human civilization, right? Like we all have our egos and our own unique perspective and thoughts, and the diversity of this is what has created innovation. So I don't think there'll be this one giant brain with only one kind of self-directed goals that would be as intelligent.
Yeah. Well, if you upload a Republican and a Democrat, you get a Libertarian.
Well, politics is something that is a thorny subject, but
So the title of this podcast is called "The More Intelligent Tomorrow." What do you think about when you think of the future in the next 10 to 20 years? And it doesn't have to be AI related. What are the technologies that you hope to see in your lifetime that you hope will be available for the next generation?
yeah, it's such an exciting time to be an AI researcher because when I started, I was working on theoretical foundations to see this come to fruition and see all kinds of exciting developments and real world impact is a dream come true. And so the next decades will be very exciting. So I'm really big on healthcare. I think in 2020, massive levels of investments went into healthcare. In fact, that was the top domain for AI. So that says how much of it is untapped, right? I mean, everything from, if you look at our current healthcare costs, they're ballooning. They're very inefficient systems in hospitals. I was shocked that they still use fax. So there's a lot of low hanging fruit that AI can quickly automate. But also deeply challenging problems like in the domain of drug discovery. If we think about all possible molecules in this universe, I think that's 10 to the 60, right? So it's like followed by 60 zeros. So it's mind bogglingly large. You can never ever go through all of them. And so, how do we come up with very accurate predictions of what molecules have the properties desirable? Right, and for that we need to understand the biological mechanisms. How effectively is the binding? What kind of pathway should this be targeting, and how should it not affect the rest of the pathways, right, and its toxicity levels. So all these like highly multi-objective systems, right, if we can get enough understanding, which we do. I mean, we in fact have the Schrodinger's equation, which is the basic equation for modeling molecules. The only challenge is it's an exponential time algorithm. So by the time you come to even reasonably sized molecules with tens or 20 atoms, right, it already takes up a supercomputer or more. And whereas with proteins, it's like hundreds, if not thousands of atoms. And so that's the one computational challenge, right? Can AI speed up these kind of precise computations? And that's something I've been personally involved in and already seeing very exciting results on better predictions. But if you think of that whole pipeline, right, from going that to doing experiments on just the tissues in the lab to ultimately whole human trials. How do we kind of speed up that entire process and use AI? And how do we tackle rare diseases that do not have mass, big pharma companies going after them because it's not profitable? I think these kinds of impactful research using AI can really bring down the costs and be of direct benefit to humanity. Yeah, so my biggest area would be healthcare.
And I imagine you were very excited to see the alpha folding results where they were able to predict the protein structures. Like that's a very exciting breakthrough.
Certainly. And that's a great example of where computation directly impacts, right, the end result, because there the algorithm is fixed, and we know how to get the reward function there. So everything is well defined. But in other parts of the pipeline, not so much, right? Like the function, like that structure, predicting function is a lot more ambiguous, right? And we have only limited data from human studies, right? So, and we can still do only limited experiments even in the lab. So, how do we make the use of those limited resources and still use the power of AI is an open question.
Yeah. Well, I hope in the future, when the next time we have a pandemic, it won't be a pandemic because we'll get the sequence, and using AI simulation on drug interactions, we can simulate an mRNA vaccine with known proteins in the human body and just roll it out quickly, right? Where it's weeks of development or days rather than. We should all be proud of ourselves for how quickly we got an mRNA vaccine out. But I hope in the future we don't have to see this amount of loss.
Absolutely, absolutely. And I think there's been a lot of lessons learned, and there's already proposal to have mRNA vaccines for flu as well, right? I mean, even flu kills a lot of people, especially the older and vulnerable population. And so now creating better vaccines for that is an immediate side effect of innovations for the COVID vaccine.
I was blown away with the mRNA vaccines because back in 2008, I was doing a senior research project with Genentech, where if you needed a protein, you had to genetically engineer a Chinese hamster ovary cell. You had to grow it, you had to explode it and lyse it, and then you had to try to purify that protein through all this junk with affinity chromatography. It was very expensive. Where with mRNA, who just came the protein factory, you and I did, which is unbelievable that that was. I'm amazed that worked. There's so much with human innovation that I think makes the idea of AGI quite intimidating, because general relativity, mRNA innovation, can you go build an AI system that will develop and begin to do that type of innovation in the future? And that's an impossible problem, or it feels so.
I think that'll only be possible with millions of AGI again, right? So if everybody, if you have one system try to figure out general relativity as well as the mRNA vaccine, it seems really confused then what should I do with this? So I think that goal-oriented behaviors that humans have, like that ability to focus and say, this is my path in life and this is my path to make a positive impact in humanity, and especially the great scientists that we are inspired by, right? That singular focus is also such an important trait.
Yeah, Anima, I've had a fantastic time talking to you. It's been a blast. It'd be easy to talk to you for many more hours. Anything you want to say to our users before we wrap up? We have a large following of data science and AI professionals. Any way they can follow your research or be more involved, or do you have any current openings that you're hiring for that you'd want to draw attention to that we can be helpful with?
Yeah, thanks a lot, Ben. We certainly are actively hiring at NVIDIA. In my group, I look for research scientists, but broadly in NVIDIA, right, all kinds of roles. The company is always expanding, and we have so many openings. I also encourage you to, check out my website and also open source frameworks that our team is bringing out. Tensorly, which is Tensor with ly in the end. Is open source framework for tensor computations, like creating neural network architectures with tensors. Minkowski engine is also on sparse tensor convolutions for 3D vision and other models. So these kinds of different open source frameworks are ways that the community can be engaged with us. This is with our group. And broadly, NVIDIA has like transfer learning toolkits and automatic mixed precision, all these kinds of capabilities, right, to help do better machine learning. So check that out.
Awesome. We'll make sure to include links in our show notes. Well, thanks, Anima. Thank you so much.
Thanks a lot, Ben. This was so much fun.